Good afternoon, people. How are you? Well, good vibes here. There are some people who will be coming after the coffee break, but we should start in time. And to start with some questions. Whom here produces a source code most of the time? Please raise your hand. Who here, whom most of the time work with management, project management, basically? And who here most of the time works with agile coach, agilist, and others? Well, good. A very diversified audience, and starting with something that I've just heard, I will not explain in source code here how we end with technical debt. Or when we talk about this issue here, what do you expect? Talk to the person next to you, do some networking. What do you expect to hear in this talk? If you don't know the person next to you, it's a good opportunity to get to know the person. Ask each other, what do you think we're going to hear in this talk? What do you think may help you solve your problem? Well, we have 45 minutes or 50, I don't know, to talk about it. Well, my my name, people call me Fusca, so call me Fusca. I will be very happy. My name is Wagner. Those are the social networks, Twitter, Wagner Fusca, LinkedIn. And if you want to hear about software development and speed, you can go into my blog. Well, I have one thing here in my pocket. It is an incredible formula that I will share with you today on how to end with the technical shortfall. It's a nice thing I have used very much in that company called Matera where I work, and we are ending with our technical shortfall. It is coming to zero, which is great. Are you interested in this? Yes or no? Very much? Okay. Who wants to pay for this recipe here? It is magical, almost magical. Who wants to buy this? Who's interested in solving this problem? Well, it is like a crystal ball. When sometimes we get together, the team gets together, we look at this, we pass our hands on that piece of paper, and the technical shortfall ends. It is something great. The project indicators get better, everything becomes beautiful, everything looks great, the company's productivity grows, everyone's happy, drinking champagne, etc. I will show you right now how to end with the technical shortfall. There's no technical shortfall. And that's the answer. Well, thank you very much for your attendance and enjoy the rest of the evening. Well, if you use this terminology, technical shortfall, somehow it came to you in a wrong way. This is something we don't have. What we have is a technical debt. Yes, let me explain to you what this means and what I mean with this. Ward Cunningham, one of the signatories of the Agile Manifest, in 1992, he created this term, debt metaphor. And I think that we Brazilians who understand English, we took debt and we understood that as being a debt. And that is not a debit, it's a debt. And let's go to the root from Cunningham, talking about a debt. He had a problem and he had to talk through a metaphor, which was one of the XP practices in the world, and XP 92. He said, well, let's talk in a metaphor with his manager. He needed to explain that the management decisions to hasten a project brings up a problem that one day will have to be paid. And how he explained this was, it was a financial product, so I will explain this using financial terms. So when you take a loan from a bank, 100,000 reals came into your account. Are you happy with that? Oh yes, and many zeros, you're very happy. Let's use this money. You buy a car, you buy a house. However, afterwards, you have to pay this debt, this loan, as fast as possible. Otherwise, you start to build up debt, and this debt buildup will become something that is almost impossible to pay. I bought an apartment, it will take me 35 years to pay. My daughter will be getting married and I'll be still paying for that. So it will take a long, long time. So this is the metaphor of the debt that Cunningham talks about. I like thinking, who had lunch today? Raise your hand. Those who had lunch. Well, that is great. Those who didn't have lunch are in a forced fasting. Well, great. It's healthy. But I believe most of you have had lunch today and you paid for lunch on with your credit card. Great. When you paid, did you say debit or credit? If you said debit, the money left your current account to the store there immediately, right? Yes or no? So this is debit. It just left your account. If you said credit, it will take about 45 days to leave your account. What happens if you don't pay your credit card invoice? Well, there's a huge interest rate for that, right? This is technical debt. You know, when you choose, you make decisions regarding your project, the way it is, or when you leave the design aside, you end up having debt and not debit. And this is what I wanted to tell you. If you remember this, I'm happy. Because, you know, in 2017, a research started that had 258 people answering the survey all over the country. Many of you may have participated, and there we have some figures. The numbers are in small type, but we can see that about 78% are people who develop software. And 15% are those who have already developed a software. So a large number of people who have already worked with a source code. Of these 258 people who answered, you would add there 65% already working for 5 or more years with software, and 9% with working with it for over 4 years or more. So we have a large number of people who already work with software, have been for some time. You know what they answered when I asked this? This term, technical debt, is it something that is fluent for you? 51% said yes, and the other half said either they had never heard or they know that as a technical debit. When I put this figure there, you see, well, half of the people who are working with this are working wrongly, do not know the concept, and they have no idea on how to deal with this. And then I started to pay attention to this topic. So this is, I don't see any problem. I do not judge you if you call this a technical debit. You are part of this 50% there, and I hope this reduces and you use the terminology technical debt. Okay, a lot of people use technical debit. If I come to the end of this presentation here and you all say technical debt, and then I'm happy. So, and how do you contract debt? Well, I'm talking about technical debt. Well, two very important factors when you want more speed. Well, a faster delivery, right? You don't have to run any test. I will deliver this. You know, the test is not here to generate value. Whenever you rush on something, when you choose speed instead of quality, you will contract a technical debt. And when you have no refactoring, you also contract a technical debt. It is almost impossible to have the best source code at a first attempt. Do you agree with me? At a first attempt to have the best source code. And there's another very bad behavior, is that we prefer much better to cut than to think about solutions later, right? First I solve the problem, then I write the source code. This is how we should think. But since we don't do it, we don't have much experience, the best programmers, and we don't have a refactoring stage. You know, if you did this all the time, you had an entire cycle. I didn't do a DDT, but we're always looking at the source code, improving it. Then you create a refactoring environment, and your technical debt will fall. So this is a very interesting chart that may be very well used for anyone, by anyone at a C level and so on. One thing important is that these slides are already available to you, and they all have references. So if you stop and look at the references, they are not of today. Most of them come from 2006 and 2012. So a topic that has been discussed for quite some time already, but we don't approach this very often in Brazil. So this chart is from 2010. Hi Schmidt, he created this chart where you can see the axis is the years, and on Y there you have the cost of change. In the first year, the cost of change starts to grow, the optimal cost. You see that it is never stuck there to the x-axis. So all change has a cost. Our goal is to have cost as close as possible to the optimization curve. So software is something that is alive. I like saying that software is like source code is like bread. If you don't eat that very fast, it will rotten, it will spoil. So it is live, it is alive. So you look at, going back to the chart there, you see that the optimal cost is always growing. But if you don't pay attention there, if you don't pay attention, you don't have factoring. There's the chart there showing that it grows very quickly. And then the current chart of change starts coming very much off from the optimal curve. The size of the eating mouth there is huge. And then you start thinking, well, here we're looking at it from 1 to 8 years. And companies, how about companies that have a 30-year software? Right? Well, this is what I have there. Maybe 10 years. Is it possible to pay off this debt? Well, by the end of the talk, you will see that. Another interesting chart, and this is a very nice paper, which was written for CFOs. It is not a technical paper. It shows all technologies have a curve, a time curve here, and there is an adoption curve and a technology use curve. If you refactor right at the beginning, the curve will close, the mouth will close. Now, if you pay attention to the other steps and you take long to pay your debt, it increases substantially. So that is why you have to stimulate an environment fostering this refactoring. Another thing besides the speed of the lack of refactoring that make your technical debt grow is an environment in which you have intolerance to fail. This image here is from Allison's talk, the software design. Some of you have taken his class, and it is an interesting image because right in the middle there, let me see if I can point to you there, right here, there is an opportunity for improvement. Whenever you write a source code, there is an opportunity to improve, always, always. That is why you have to refactor. What do you do then? You do the improvement. I execute, it's right, great. So you create a motivation. Great, it worked, the test is green, etc., etc. We always do that. Right? There are teams that do this. The test went okay, so we are happy. But sometimes you execute it and there's an error, red. So what do? You create a culture of learning, and then you go back to the cycle, or you start with a culture of blaming for the mistake. In other words, a culture that does not allow people to fail. Well, there's a problem here. You start whipping people, and you are nurturing this environment of pointing blame. And whenever you create this environment of pointing blame, you have an environment of omission. So people would say, how is your system? Do you nurture an environment that deteriorates or one that optimizes? So this chart is really nice. Whenever you create a culture of improvement where you try to pay this technical debt, this generates optimization. If you don't have an environment where you try to pay your technical debt, you continue increasing the distance between the optimal curve and the ideal curve. Questions? So 3 ways to have this technical debt. When you try seeking speed, when you don't have a refactory environment, when you have an environment that fosters assigning guilt or blame. And until it comes a time that when you have a debt, somebody will come collect that debt. Alexandre Freitas is here? No? When I met this talk, it was because Alexandre Frei and I have to acknowledge this. In 2011, I saw this, and my life really changed. It was the talk that changed my life. And he used this imagery. One day, somebody will come collect this debt. You all know Chaves, there, Chaves, and and Mr. Belly there. I'm not sure if he's the best debt collector. Is he? He's a very bad debt collector. Never he will pay this debt. So there is a person that comes collect a debt. This federal agent here, he is the one that would come very early in the very early hours of the morning collect a debt. So I believe that technical debt is this. This is the guy that will come collect. And he is so great that he arrested himself. There you go. So he is the best debt collector. One thing you have to understand in technical debt, and if the chart is very small, there the reference is here for you to look at later. You have what is technical debt? If you have a situation, do you have information? No, it is not technical debt. Can you execute it again? Is it a technical debt? If you can't, it is not a technical debt. If you can execute, yes, it is. It is a defect. And this type of defect, what is it? Well, it is really a bug. Bug is not a technical debt. It has never been a technical debt. A technical debt, the system is working. Bug is a bug. We have to know that. But if this defect is something that you look at and it is a design task, when I say design, it is not website, I'm talking about source code. You used the wrong architecture, you used, solid and other things, wrongly. I'm not dwelling in details here, but you had a wrong design. If you can measure this, yes, then this is a technical debt. If it is not building up, that's it. Don't work with this now. No, let it build so you can pay this debt later. Okay? So we have seen that bugs are not technical debts. When we look here on the next day, well, it is not a defect, it is a system increment. The system increment, is this a new task? Is this something new? New things are not technical debts. They are new things. No, you saw that it may be a system increment, and then you see again, well, it is a design limitation. Does it build up? If it builds up, it is a technical debt. If it doesn't build up, it is not a technical debt. So this is a graphical way to understand what a technical debt is. Important thing is that default or defects are not technical debts. And our great friend Uncle Bob, one of the signatories of the Agile Manifest, said on his paper in 2009, he said, a mess is not a technical debt. Okay, so if you look at your source code and you think it is a mess, it is not a technical debt, not according to our friend Uncle Bob. And I ask myself, is it really? Am I going to treat my software as a mess because I have a 30-year product there? I have a product there that I don't know even where to start with. It looks very much like this here. So what do I do first? Maybe availability. Well, let's look at what Uncle Bob says. A mess is not a technical debt. He says it is only a mess. The technical decisions of indebtedness are taken based on real project restrictions. And he says this very lightly, that the decision to make a mess is never rational. It is always based on laziness and lack of professionalism. Uncle Bob is Uncle Bob, but I still like him. And there at the end he says, when you decide to take on a technical debt, it is better to make sure that your code remains totally clean. Keeping the system clean is the only way to pay up this debt. Okay, so what I ask myself is that for Uncle Bob, mess is not a technical debt. It is lack of professionalism. It is working like an amateur. And this is when you are in debt with your team. Do you have a team of professionals or a team of amateurs in your development team? And that's the idea. What are you doing to make them professionals? So this is something you have to pay attention to. So with this, you are a factor of change, of transformation. But another person that I believe it is also very important here is Martin Kohler. And looking at what Uncle Bob said, he said the same. He wrote another paper in 2009. He wrote there answering Uncle Bob. He created these quadrants here, and he said, well, this matrix thinks that you make decisions as with a prudency, so you are prudent or not, or deliberate or inadvertent. So I try to summarize this in an easier way to understand, because when you read his post down there, it is not very easy to understand. So there are times when you know that that is a technical debt, and you then choose to contract interest. There are times when you have to deliver something, and you will do this without a test. You will do it without trying to get to the best design, and you know that. You are aware of that. It is a conscious decision from the team. They see we will contract a debt, but we will deliver. We will deliver. So it is a prudence. I know I am contracting this debt. The ideal situation that you know in the next iteration you pay this debt up. There's a time when you are imprudent, deliberately, in which you say, I don't have time to pay this debt, I have to deliver, when you try to have more output than value. Right, as we saw that in a talk today, you look for more way outs. Deliver. This is in that quadrant. You are a deliberate imprudent. You know what you're doing. You have no posture to say from here on this will not happen like this. No, this is a professional posture. A professional stand. And looking there at what Martin Fowler says, there is a mass here which is a technical debt. When you are imprudent inadvertently, which is the best scenario, those people who are working and writing code after code and all bad code. So this is the worst profile. They are increasing the mass. And there is a last quadrant, which is the prudent inadvertent, which is very difficult to explain. Imagine you deliver the project, the customer is happy, the team is happy, everything's beautiful, but what happened was that when when you feel like this could have been better, well, instead of using that project pattern, we could have used the other one. Well, for that situation, we could do like this. But everything is beautiful, but you want to make it even more perfect. So this is the last type of technical debt here. And then our friend Martin Fowler says, good design and clean code make you go faster. And this reminds me a principle from Agile, which is continuous attention to technical excellence, and good design increases speed, agility. Sometimes we have to produce more. We want to be faster in our teams, and we are not paying attention to this here. In other words, you can only be faster when you have an environment when you are paying your technical debt. I said many things, but now I want to give you the secret. How can we pay up this debt? Because afterwards you cannot pay technical debit because it doesn't exist. So let's go on and see how we can pay for this debt.
Does anybody know this person? Simon Sinek. Fine. Many of you know him because of the Golden Circles or the book The Leader Always Eats Last. But he has mentioned a lot, and his last TED is available, called The Infinite Game. When I heard this, my head mushroomed, and this was in my mind for months. What is an infinite game? His new book will be released in October about a new game, and we as leaders, how do we play this game? There are two types of games, finite and infinite. In finite games, the rules are very clear, and you know exactly what is the objective, and the players are known, like soccer, football, baseball. All these are finite. There's a beginning, there is a middle, there's an end. And there are the infinite games where rules are changeable, players are unknown, and players keep on playing. There's no victory. There is being behind or in front. Question for you who work with software or in any other area. What does software look like? Something finite or infinite? Infinite. And here's a critique. We want to work with software as a project with a beginning, a middle, and an end. and the software will never end. And I have to tell you, technical debt will never end. You will never equate it. And this year, I saw this posted by somebody in Holland, and he made the best analogy I've ever heard about technical debt. Many of you have spent many hours playing text in that thing that was gray with two batteries behind it, and it was my case. I was a nerd. I spent hours in that. And he makes this analogy. It's like playing Tetris. You will never win Tetris because it was endless. You can only control how fast you're losing. Your objective was always to maintain the minimum number of parts. That is the metaphor I wanted to leave with you. A technical debt is infinite. Software is an infinite game. What can you do to control how much you grow your debt, how much you decrease your debt? I think in 2013 there was a book called Essential Scrum. I think some of you have read it. And this is so interesting, another critique. I'm inspired by Uncle Bob. We talk so much about Scrum. We don't talk about technical debt. But there's a 40-page chapter talking about technical debt. And as far as I worked for 6 years with this, I never saw or heard teams talking about technical debt. And it presents 3 ways of managing your technical debt. Manage the acquisition. Manage, bring visibility, and pay your debt. This is the triad that I have worked with, that I have considered, that says this: a technical debt means that you control how you purchase, how you acquire. You have to bring in visibility, because if you don't bring in visibility, you have hidden work, nobody will mind it. You pay. And the metaphor of the hole, I don't know whether you know it, but you're inside a hole. What do you do to get out? You stop digging. That is to say, stop creating technical debt. And after you stop digging, how do you get out? You create something that will show you that you're climbing up. And what you do, you draw dirt from one side, and you create a step so you can climb out of the hole. And talking about acquisitions, we could say this: create an environment of quality. Some terms that I'm not sure you know. Yagne. Who knows what the Yagne is? Raise your hand. You ain't gonna need this. You ain't gonna need this. The best way of not creating technical debt is not to create font codes, source codes. And not only, this is not codon. This is an item that's been mentioned, it's just sort of forgotten. Don't go codon, you're not going to need it. You wait it until very late to add some complexity to your software. Keep it simple, stupid. Yes, simplicity is a principle, isn't it? Simplicity, or the art of maximizing the work that doesn't need to be done. Have you read about this? Clean code, that is, clean codes. Or how can you have a technical debt payment environment if you don't teach what code cleaning is? People will keep on adding technical debt and then refactoring. When you have an environment where you control acquisition, then you have a landmark, and from this part up, you won't grow. And you start paying, you see the interest expense will decrease because you're being disciplined and paying out your debt. Klaus Busterfelden, I have some difficulty in pronouncing his surname. He brought us to Brazil in 2011. I was attending this lecture in 2011, and I was very happy, brand new programmer. I heard this, and I'm so thankful to Juliano Ribeiro because he recorded this and left it in YouTube. The name of the lecture is The Dilemma. What is the dilemma of every software team? To deliver quickly or deliver with quality? Do you have this dilemma? Nod your heads. Let me see if you're all awoke. Deliver quick or deliver with quality? And deliver on Friday at the end of the sprint for the review. And then we're not going to present this. We're ashamed. We're going to present it. How do you deal with this? During this lecture, he says, Klaus shows us this equation. It only mentions this, and I try to write it down. Things that he encourages. That's for you to understand the mindset of somebody who thinks about a quality environment. He says, nice. We're going to have 10 people will program. 2 of them will do things that will improve on other people's work. This is what he does. 1 person per month will increase the productivity of people for 12 months. So it's 1 divided by 120 is 0.8%. If 1 person brings 0.08% productivity gain, that is by creating an environment with automated tests, by paying some technical debt, finding a new way of doing the source code, you've paid for the investment in this person. What you see the most in software team is what? Everybody drawing tasks to themselves. How can you nurture such a quality environment? Somebody has to do it, and it is not the research and development area. They do something else. And if you stop writing bad code, rough code, your quality will stabilize. But if you continue to write bad code, your productivity, your speed drops. I think this is interesting. Usually gets a very short time and can capture all the time of a pit stop in Formula One, where everybody has a clean environment. There's no mess there. Everything is uncoupled. Each one of them have a responsibility, and so they replace tires and fuel up the car in 2.3 seconds. That's plenty quick, ain't it? This is the equation for us to be very quick. If you want to make an analogy with Agile, go ahead. Without a technical debt with the clean software and so forth. And they train a lot. They don't train during the match, during the race. I'm not sure of how you handle this in your development. Professional developer trains at home, but you need some sort of a mob programming, as you heard today. When you think about technical debt, you have to bring in visibility, and Sonar Cube, Sonar Lint. And Sonar Cube is an interesting tool. You run it and it will show you what is your technical debt. Don't be scared. If you don't look, you don't know how much. And Sonar Lint is very cool because you're programming, following your idea, and you will know what is your bed code. This is the best thing for programmers, and it's not hugging trees or other stuff. We heard about acquisitions. Now we're going to talk about invisible work. This image is very cool, talking about technical debt too. We have some facility understanding new tasks, new things that we have to do, and we have the visibility of defects that we've created. And indeed, there is a gigantic world of things that are invisible, which are technical debts, architectural code, complexity, code smells, lack of tests and lack of documentation, which can be a technical debt too. And this is a very cool clue. What do you do about visibility? Put it in a chat. You know about this, the idea of Fábio Pereira, proposed in 2012. Put it on the board and in a chat, and then people will see how much effort for pain, and which is closer, attack it. Those who are here will create a lot of effort, postpone, push it ahead. And the least effort and create more pain is what you pay first. Technical debt. You have a gigantic software. You have to choose well what your movements are. And in 2016, isn't it? There is a proposal of a table where you enter how much effort you will have to undertake to clean up. We're talking about visibility. We're talking about backlogs. Don't raise your hands, but think about it. What was the last technical debt card in your board, in your Gira, in what? Normally there isn't. Don't worry about it, but here's two suggestions for backlogs. How can you work? If you have visibility, you will have the cards someplace. You will have a board, a backlog, a technical debt, and another one of demand. Is this nice? I will not answer that question. And you have the idea of 80-20. 80% of delivery of new features and 20% things to pay technical debt. Or mix up everything, which is the second image. Which one is the best? I'm still experimenting. I don't know. Provide visibility. We talked about acquisitions, control acquisitions, visibility, and time to pay up. How do you pay up? Pair programming, mob programming, toujours, DVD, and so forth. Many other things. Then you need to pay up somehow through a number of practices. It is not very cool to for one person to pay technical debt. Everybody has to participate, and there are tools. Mob programming helps out, and you have to adopt discipline. After all, it's years of debt being contracted, which you will not pay in a month, which you will not pay in a year. You will pay for a long time. And by paying up your technical debt, it is all but natural that all other metrics will improve. Suggestion of metrics that I obtained from a post. There's a critique here about the comment. Comment doesn't have to be in a code. I'm in a line that code speaks for itself. If you write bar, that means that is nonsense. Explaining a code is wrong. But these are the metrics that you have to add, and you have to have some score. If you don't have the game score, you don't know whether you're winning. But what is a good number? Begin with any number, fella. I have a suggestion. I can give you a suggestion. I've worked in an environment with 70% of test coverage, and indeed, people only made make up. They created a number of things and created no value. And you will understand that one metric has to match another. And a few last questions. There's a time where you have to ignore, is there a time where you have to ignore technical debt? Yes, sometimes you want to be too precious. And this is not bothering anybody but the developer. You have to help the developer understand that he doesn't have to pay it. It is not bothering anybody. You don't have to pay the technical debt. And this is a summary of what I've said. This is much too small, but I said there's no such thing as technical debt. The metaphor, well, there's no technical debit. I explained to you the metaphor of debt. I explained to you what is contracted when you want greater speed, and you don't have refactoring, and you don't have an environment that is resistant to failure. What is technical debt? What is it with a bug new feature? And mass is not technical debt. And the view of Martin Fowler. What is a technical debt? When you know, when you don't know, when you have time, when there's a mess. How to pay it up? Understand that this is an infinite game. You will never clear your debt, but leave it clear to the idea. And you have to manage acquisition, bring in visibility, pay up, and sometimes ignore. Much of the content I brought to you is based on a doctoral thesis of Professor Graziella Simões. You can read it. It's a very complete thesis. There's a number of items that I plugged in here, and she has a mental map on technical debt. And this is the mental map of the entire thing. What you want to hear about evolutionary design. Martin Fowler has something about it. And on the last issue, has anybody seen a project with zero technical debt? Well, the Java, there is a technical debt because you have to, because that is the print is going to be included. You have to use logger. And there's somebody called Homeophilis. He talks about testing, and he has a very nice project in DDD. And you look at the metrics, zero technical debt. It is very cool. And I had another project entirely in the PDD, and the sonar, the metric. But when I came in, you know what happened? I created the technical debt because I couldn't do it properly. But I had to deliver it, so I chose speed. The customer was looking over my shoulder. I'm ashamed of saying this, but I paid up the debt. Okay? And we have vacancies there. We have slots. If you want to come join us either in Campinas or in Maringá, and most companies, like most companies, we have a lot to offer. And I posted something about deteriorating how your software deteriorates. Slides are available here, and these are all my social networks and contacts. Thank you very much for the opportunity, and now I would like to entertain any questions you may have. Does anybody want to ask anything? Questions? It was either very good or very bad. Congratulations, Fusquet, again. I recommend reading your blog. It is a very good blog, and even for those who haven't programmed in a long time. But there is a question. When companies begin to look at their growth, and there's the case of many companies in the marketplace, and they begin hiring, the company falls into the trap of either I have a tall stick, or I flexibilize and I decrease my requirements, and this will immediately reflect in the manner by which this company operates. Do you have any recommendation of the cases you've seen, of the companies that you've seen being successful in this area? What could work? A tech lead or architecture, or something that is predefined, something that is more restricted, or some some technical rounds for evaluation? What do you suggest? What I saw is for a person to have a good onboard. That is the person's entry involving a long period of pairing up with more senior people in the company. I don't like the word senior, as a matter of fact. I have some divergences regarding the expression. But when people are the longer this person is training before being allowed to play, the better. And if you keep the person pairing up and learning the good practices of the company, if the company has a good culture, which is another challenge, that is better. A successful onboard creates a lot of value. Oftentimes, people are hired 1 week training, and then we have to bring in tasks, and this will tend to increase technical debt. And this person should have, in the first month, this person could do something outside the company, in the sense of the company works with the bank software. They could do hotels too. And people will say, let's pair up for a couple of hours, and somebody will mentor. And it's about a month mentoring, and then some product, and pairing up, and a month later this person can be turned loose. That is a way of reducing company producing poor code. When a person comes in and she is given this attention, this person will grow a lot. Company will be happy and will chase capacity building and learning new things. It is important to think this. I like people onboarding. And I think it is interesting. People coming into the company and watching videos. Spring Boot videos, this is not very effective. Somebody has to be there and pairing up. It is important for a person to look at it. And programming is looking and learning. Yes. Good afternoon. First, very cool lecture. Congratulations. What are the clues that you have for people who have to convince the business area that who don't have any idea, any contact with the development, that we have to invest 20% or more to pay for the technical debt without having a manner of checking that with productivity the team will improve performance with zero debt? Well, Woody has given you some information. The debt metaphor, if you look at the Ward Cunningham video, he describes on a step-by-step basis the difficulties that he saw and understand how he led the conversation with his director. And I like the idea of the cost of change. Imagine every manager should know that changing software entails cost. And how do we want to pay for that? Very high debt, which is interest-bearing, or do we want to pay up as soon as possible? And along this theme, if you're working on a theme where there's no slack, you have to solve for this earlier. This is beyond debt. This is your system that is overloaded. You have to create some slack for people to do Dojo or something else. Did I answer your question? Anybody else? Last question? Good afternoon. My name is Mahlani. I hail from Brasilia. Congratulations on your talk. Tell me, what is the acceptable percentage of technical debt? That is, according to the metrics. I don't know whether it is a percentage. What is an acceptable figure such that we can maintain the margin or to check and watch time going by and have a task force? I'm sorry, I have no magic number. I'm very sorry. Seek the smallest possible. As an indicator, think about this. I don't know. A crazy idea I've just had. Talk to your team. People, we need to change such product. By the number of funny faces, you can tell whether it is high or not. By their reaction, you can tell it. I just invented this. It works very well. When people shiver, it is high. When you use Scrum, plenty poker, and you see that cards inflate, there's a lot of technical debt. When people can play their cards easily, debt is controlled. Anybody else? Well, I'm available throughout the event. My pleasure being with you. And there's my contact. And have a nice event. See you later.